This is the beginning of a new chapter which is called factoring. And what we're trying to do is we're trying to express a given polynomial as a product of factors. So what we want is we're trying to get them to look like a product of factors like this. Okay, so anything that's plus or minus is put in the parentheses, but your final answer has to look like product. So in other words, it's one single term. So before we start on how to do this, there are a few rules that we have to consider, and the first rule is, do you know how to find the GCF, which stands for the greatest common factor? So take for example, let's look at the numerical example. For example, what is the GCF of say 147, 84, and 126? What that really means is, what is the biggest number that can divide 147, 84, and 26? And the trick is we need the biggest one. Okay, so one of the methods that you were taught in the earlier class is you could think of prime factorization, where you take your 147 and you break it down. So what can go into 147? So let's say 7 times 21 makes it 147. And 7 is prime, so we can stop. And 21 is 7 times 3. So what we've done is write 147 as 3 times 7 squared. So do the same for 84. 84 is, say, 4 times 21. And 4 is not prime, so I break it again into 2 and 2. And 27 is 3 times 7. So this is my prime factorization for 84. So let's write it as 2 squared times 3 times 7. Finally, let's do it for 126. 126, I could say, okay, 2 goes into it. 2 times 63, for example. 2 is prime. And I'm going to break down 63 as, say, 7 times 9. 7 is prime, and 9 is not, so I have to break some more, so you get 3 and 3. So 126 is 2 times 3 squared times 7. Okay, so now that I have them in their prime factored form, how would I find the GCF? Okay, so the rule for the GCF is you are supposed to take the least exponent. So if you have a choice, take the least one of each common factor. So you need to take numbers that is in everybody. So if you look at 2, 2 is in 84 and 126, but not in 147. So you can forget about 2. Look at 3. 3, 3, and 3 squared. These are what you call common factors, and if you have a choice, do you take 3 to the power 1, 3 to the power 1, or 3 to the power 2? So according to the rule, you're supposed to take the least one. So 3, 3, and 3 squared, you use 3. Between 7 squared, 7 and 7, you will use 7. So the highest number that can divide them all is 21. So 21 works for all of them, and it's the biggest possible. So this is what you do when you are looking at numbers. And the same rule applies even for algebra. So consider as example 2, if I were to say, can you find the GCF of, say, x cubed y squared y cubed, and x4 y cubed z. Okay, so you notice that in algebra that just means multiplication right there. Okay, it's all multiplication. So it looks exactly like how the prime factorization looked like. It's all multiplication. So according to the rule, I'm supposed to take what's common. So what's common is x cubed, x squared, and x4. But there's the difference in all their exponents. So which one should I take? And according to the rule, I'm supposed to take the smallest one. So in other words, which is the one that will divide them all? So you notice x squared goes into all of them. So x squared is taken because he's the one with the least exponent. Now I'm looking at y squared, y cubed, and y cubed. So again, I have to take the least. So that's going to be y squared. Now how about z? Do I take z? So you notice that z is only in the last term. It's not in the first two. And you need what's common. So you got to be in everybody. So do I take z? The answer is no. So the GCF in this case is x squared times y squared. So for example 3, let's combine numbers and letters. Okay, so find the GCF of say 4x cubed y4, 6x squared y squared, and 12x to the 5th yz. Okay, so now if you look at the numbers, 4, 6, and 12, what is the biggest number that can divide them all? So that's what greatest common factor mean. Okay, so it's the biggest number that can divide 4, 6, and 12. So you notice the biggest number is 2. So you don't have to do what we did, but if you cannot see it, you can break down the 4 as 2 and 2, which means it's 2 squared. 6 is 2 times 3, and the 12, if you break it down, is 4 times 3, which is 2 and 2, so that makes it 2 squared times 3. So you notice between 2 squared, and 2, your GCF is the smallest one, which is 2, and 3 is dropped, because 3 is not in the very first one. So again, GCF is 2. So for small numbers, you could just eyeball the answer rather than doing the work, because I think it's if you're looking for what can divide 4, 6, and 12, there's really only one choice, 2. Okay, that will work for all of them. Alright, now I'm looking at x cubed, x squared, and x fifth. So between x cubed, x squared, and x fifth, remember you need to take the one with the least exponent, which means it's x squared. And between y4, y squared, and y, the least exponent will be y, and z is dropped because he's not in everybody. So this question, the answer is, the GCF is 2x squared y. So you notice that in chapter 6, instead of asking you for the GCF, we kind of phrase it in a different manner. What we do is we will ask it to you this way. So rephrased as a factoring question. Okay, this is how we'll say it. Can you factor 4x cubed y4 minus 6x squared y squared plus 12x to the 5th yz? So instead of separating the terms with commas, we are using things like plus and minuses. But as we mentioned before, this still means that there are 3 terms. Okay, there are 3 terms because they're separated by plus and minus. So look for GCF. Check for GCF. That's the first thing you should always do. So you notice that you're supposed to look at them like 3 separate terms. And as we saw in example 3, the GCF is 2x squared y. Okay, so that's my GCF right there. And then what you do is you start a parentheses, and that becomes your reduced polynomial. So factoring, if you think about it, is really the reverse of distributing. So we are trying to ask ourselves, 2x squared times y, what must I multiply in order to get back the 4x cubed y4? Okay, I need to get back that one. So 4 is 2 times 2, so that takes out the 4. For x cubed, I have an x squared on the outside, so I need 1 more in the inside. And for y4, I need 3 more. Okay, so if I distribute, you will get back your 4x cubed y4. Okay, there's a minus right there, so put it back. Now I'm looking at how to get my 6x squared y squared. So with the 2, I need a 3 so that I get my 6. x squared is already there, I really need only one more y. Okay, plus right there. Now I'm looking at the third term, and 2 times what will give me 12? The answer is 6. And if I have x squared, I will need 3 more, so that in total I have 5. Y is out there, and I need the z. Okay, so how can you check that you are correct? You can distribute, okay, and then you will be able to get that. So from here to here is what we call distribute, but now we are doing the reverse from here to here, and that's called factor. So factoring is really the reverse of what we learned in chapter 5. Okay, let's try another example. Can you factor 5x cubed plus 15x squared? Let's say minus 5x. Okay, so what is common? In other words, what will divide 5, 15, and 5? Okay, so the biggest number that can divide them all is 5. Then I'm looking at x cubed, I'm looking at x squared, and I'm looking at x. So the GCF requires me to take the least exponent, which means I take out the x. Straight away I start a parentheses, and then I'm asking myself 5x times what will give me back my 5x cubed. So that tells me I need 2 x's, plus right there. 5x times what will give me 15x squared. Okay, so I'm looking at this right now. So it tells me that I need a 3, because 5 times 3 will be 15, and I need 1 more x. And finally, the minus right there. Now, what times 5x will give me back 5x? So you notice the answer is 1. So take note of this. You have to put this back. Okay, so you have to put it 1. So every term will have a reduced term inside the reduced polynomial. Now, an interesting fact to note, the original question came as 3 terms. 1, 2, 3, because it's separated by plus or minus. This is what we call 3 terms. Okay, but when we factor, you notice these are all product. Parentheses is treated as one big family. Okay, so it's 1. So this is all multiplication. So this is really just one term. So you notice that for you to factor, you're really trying to express things from many terms into one big term. Okay, and any plus minuses are being tucked away in parentheses. Now, the thing that you have to remember, now this is an agreement that we're going to have right now, if the polynomial, okay, if polynomial begins with a negative term, factor out negative 1. That's what we're going to agree on. So let's make sure you understand what we're talking about. Take, for example, can you factor, say, negative 2 plus 5z? Okay, so the agreement is if the first term begins with a negative, you're going to factor out the negative, and then you have a remaining polynomial. In this case would be negative 1 times what will give me negative 2. I need a positive 2. And for the 5z, it now becomes a minus 5z. So in factoring out the negative sign, so what you do is you factor out negative 1, and then you switch the signs. So let's try another one. Supposedly we say, can you factor negative 3b squared plus 12b minus 15, for example. So because it begins with a negative, so I'm going to take out the negative, but not 1 this time, because between 3, 12, and 15, what can divide 3, 12, and 15? The number 3 does the job. So I should be factoring a negative 3 instead of just a negative 1. And then I will have a reduced polynomial. So negative 3 times what will give me negative 3b squared. So that's what you have to think. And the answer is you need a b squared. Negative 3 times what will give me a positive 12b. So I need a negative 4, because negative 3 with negative 4 makes it positive 12, and I need a b. And negative 3 with what number will give me a negative 15, so I need a positive, and that will be a 5. So you notice that anytime you factor a negative, it always forces you to change the signs, okay? But it's not always negative 1. Sometimes it's a different number. Okay, let's see if you can notice this thing. What if I were to ask you, can you factor, say, let's try this. 3a, parentheses, 1 minus 5b, and then minus 4b, and then 1 minus 5b. So the first thing you need to notice, there's one term here, and there's one term there. Okay, so between these two terms, do you see what's common? So you notice that in both the terms, 1 minus 5b is there. So what you do is you take 1 minus 5b out, that becomes your GCF. And then straight away you start a parentheses for the reduced polynomial. Okay, so who is the reduced polynomial? In the first family, or the first group, you notice 1 minus 5b is removed. So 1 minus 5b multiplied by what will be what you need. You notice what you need is just this, 3a. And then in the second group, because 1 minus 5b is removed, so it's like this, you removed it. So it's what, 3a left. In the second group, 1 minus 5b is like removed. So what you have is going to be negative 4b. So that becomes your final answer. And you notice that instead of 2 terms, now you are left with 1. Okay, so you know you're done. So the next part, let's call this rule number 2. The next part that you have to consider is factoring by grouping. So how do you know you have to use factoring by grouping? So this usually applies to polynomials with 4 or more terms. Okay, so when there's 4 or more terms, that's when you think of using grouping. So let's do some examples to make sure you totally understand this, and then you need to practice. So let's try. Can you factor 2a cubed plus 6a squared plus a plus 3? So you notice that this polynomial has 1, 2, 3, 4. 4 terms. Okay, so when there's 4 terms, you think of grouping. Now this is what it means. You're going to put them into 2 groups, still separated by a plus. So you have 2a cubed plus 6a squared into one parentheses, and the a plus 3 goes into the next parentheses. So in doing so, you are really splitting them up. Okay, so now if you look into the first group, you notice that their GCF is a 2, because 2 and 6, the biggest number that can divide it is 2. And between a squared and a cubed, you need the lower exponent, so that's why it's a squared, and then you start a parentheses. So 2a squared times what will give you 2a cubed is going to be a plus 2a squared times what will give you 6a squared, that's a 3. Now in the second group, you notice that there's nothing that goes into them. Now if there's nothing that goes into them, it means 1. 1 times a plus 3 is a plus 3. Okay, think like that. So now in these 2 groups, do you notice that a plus 3 is common? Right there. Okay, so that tells you that a plus 3 is your GCF. And then you start a parentheses for your reduced polynomial. And this time your polynomial will be a plus 3 is removed, so you're left with the 2a squared, and a plus 3 is removed, and you're left with the plus 1. And then you're done. Okay, let's try 2 more examples, and then you need to practice. Okay, let's say, for example, you wish to factor 6x squared plus 2xy minus 9xy minus 3y squared. So if you look closely, it's 1, 2, 3, 4. 4 terms, okay? So start with 2 big parentheses separated by a plus. So you have 6x squared plus 2xy in one parentheses, negative 9xy, negative 3y squared in the next parentheses. So in the first parentheses, you notice that what is the GCF in this case? So just focusing on these two, the GCF is a 2, and next. So what's in the reduced polynomial is 3x plus 2x is removed, so that leaves me with y. Okay, now in this next parentheses, you notice it begins with a negative. So that means I have to take out the negative. And when plus multiplies to negative, it becomes negative. Okay, so that's why the plus disappeared. Between 9 and 3, I have to use 3. I have to take out the 3. X and nothing, I have to leave it. And between y and y squared, I take out y. So 3y times what will give me negative 3y times what will give me negative 9xy. That tells me it's positive 3x. And negative 3y times what will give me negative 3y squared, tells me it's positive y again. So if you note now that this is 2 groups, and again, between the 2 groups, there's something in common, 3x plus y. Now bear in mind, there must be something in common for you to remove, okay? So if you don't see anything in common, you must have left out something. You probably forgot to change the sign, so watch out for that. So what's common, take him out, that's what we call the GCF, and then you straight away start parentheses with the multiplication right here, that's called the reduced polynomial. Okay, so if you go to the first group, you notice 3x plus y is removed, so what's left is 2x. And in the second parentheses, 3x plus y is removed, so what's left is negative 3y. And that's the answer. Okay, one more example. Let's say, can you factor 2y cubed minus 6y squared minus 4y plus 12. Let's try that. Okay, so 1, 2, 3, 4, 4 terms tells me it's grouping. And I'm going to use 2 parentheses separated by a plus. So first 2 terms goes in, 2y cubed minus 6y squared. Then the next one, remember the negative belongs to the 4y, so take him with you. So negative 4y plus 12 goes into the next parentheses. Now in this first parentheses, you notice that between 2 and 6, what divides 2 and 6 is 2. Between y squared and y cubed, I need the lower exponent, which means I have to take out y squared. So what's left is going to be y minus 2 times 3 will give me 6. Okay, now in this one you notice that it starts with a negative. Okay, because it starts with a negative, remember our deal, you have to factor out the negative. And 4 and 12, what divides 4 and 12 is going to be 4. Okay, and then you start a parentheses. Negative 4 times what will give you negative 4y? The answer is y. And negative 4 times what will give you positive 12? The answer is negative 3. So you notice that y minus 3 and y minus 3 is common right there. So take them out. That's my GCF. Okay, and then I start a polynomial. That's my reduced polynomial. And y minus 3 is removed, leaving me with 2y squared. Y minus 3 is removed, leaving me with minus 4. Now, if you stop there, you are still wrong. The reason is because, look at this polynomial, 2y squared minus 4. There is a GCF. 2. Watch out for that. So that means that you actually have to do further. So you have to take a 2 out of this parentheses, leaving you with y squared minus 2. Now this being multiplication, you normally just bring the 2 to the front. So the most preferred way is numbers always come first. So that's why we send the 2 all the way to the front. And then the polynomials come after. And that's the answer. So always check for GCF, even in the reduced polynomial. Okay, so watch out for that.